In this video, we are going to solve problem 30. In problem 30, we are given a polynomial, f of x equals x to the fourth minus 7x to the third plus 14x squared minus 38x minus 60. And they tell us one of the zeros. And it is our job to find the remaining zeros of this function. Now, since the degree of f of x is equal to 4, that means there are at most 4 unique zeros. So we have one of them, we need to find 3 of them. Notice that this polynomial, all of the coefficients are real numbers. If that is the case, and we know one of the complex zeros, then if you have a complex zero of a polynomial that has real coefficients, then the conjugate of that complex zero will also be a zero. So since 1 plus 3i is a zero of f of x, so is the conjugate 1 minus 3i. And what we're actually going to do here is we are going to multiply, let's see. Thus, since both of these are zeros of f of x, x minus 1 plus 3i, and x minus 1 minus 3i will both be zeros. And notice that I put these complex numbers in parentheses. And then I can simplify them. Distribute that negative sign and we get x minus 1 minus 3i. And remember, the negative just changes the sign of both numbers inside that parentheses. And so this becomes, my positive 1 becomes negative 1, my negative 3i becomes positive 3i. And what I want to do is we're going to multiply those two factors. All right. And the reason we're doing this is because if both of these are factors of our polynomial, then if I multiply the two numbers together, the resulting polynomial will also be a factor of our polynomial f of x. The way to think of it is like this. 2 and 3 are factors of 12, right? And 2 times 3 is 6. That's also a factor of 12, right? If two things are a factor of another thing, then when you multiply the two factors, what results will also be a factor, if those factors are prime, or if they do not share a common divisor. All right. Let's go ahead and we're going to multiply everything in the right-hand parentheses by x. So this will be x squared minus x plus 3ix. I'm going to multiply everything in the right-hand parenthesis now by negative 1. So that will be negative x plus 1 minus 3i. And then finally, I'm going to multiply everything in the right-hand parenthesis by negative 3i. So that will be negative 3ix minus plus 3i, and then minus 9i squared. Some of these things will cancel out. These are going to cancel out, and these are going to cancel out. And if you are ever multiplying two factors that we got from zeros that are conjugates of each other, all of your i's should cancel out. If they do not cancel out, that means you made a mistake somewhere. All right, let's put together our x values. So these are like terms, so that becomes minus 2x. And then negative 9i squared is really the same as negative 9 times negative 1, which is positive 9. And positive 1 plus 9 will be positive 10. Because remember, I squared is the same as negative 1. Now, what we are going to do next, we have a new factor of f of x, and so we can factor it out of f of x. Now, since it has an x squared term, we can't use synthetic division, but we can use long division to do this. All right. So, what do I multiply x squared by to get x to the fourth? The answer would be x squared. And now I'm going to multiply everything by x squared, everything on the left. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. And x squared times 10 will be positive 10x squared. I change all of my signs, and then I add these two rows together. The x to the fourth cancels out. I end up with negative 5x to the third positive plus 4x squared, bring down negative 38x. All right, what do I multiply x squared by to get negative 5x to the third? That would be negative 5x. So I'm going to multiply everything on the left by negative 5x. So that would be negative 5x to the third plus 10x squared minus 50x. Again, change all of my signs. I end up with negative 6x squared plus 12x. Bring down our negative 60. What do I multiply x squared by to get negative 6x squared? That would be negative 6. And again, here I'm going to multiply everything on the left by negative 6. So I get negative 6x squared plus 12x minus 60. And when I change all of the signs and I add them together, I get a remainder of 0. And that should be the case in this case, because we said that x squared minus 2x plus 10 is a factor of f of x. So when I divide by x squared minus 2x plus 10, my remainder should be 0. If it wasn't 0, I would know that I must have made a mistake somewhere, either in the dividing or maybe I got the wrong number in the step before it, or the wrong polynomial in the step before it. All right. Now what does this mean? This means I can express f of x as I have two factors. The original factor was x squared minus 2x plus 10, and now I have a new factor, which I found by dividing. And so that will be my second factor. And the key is I am trying to find the zeros. I already have two zeros from this first one. I know it's 3 plus or minus I are the zeros from that first polynomial. But I want to find the zeros using the second polynomial. Now luckily the second polynomial is quadratic, so I can just use my understanding of solving quadratics to figure out when is x squared minus 5x minus 6 equal to 0. And in this case, I'm going to see, can I think of two numbers that multiply to get negative 6 and add to get negative 5? I can. It would be x minus 6 and x plus 1. And so those, I can factor this out, which means that my zeros are positive 6 and negative 1. So at this point, I have found 4 zeros. This was of degree 4, so I've found all. There can't be any more zeros. These are all of the zeros. It can't be more than 4 zeros for a polynomial of degree 4. And so our final answer, zeros of f of x, are 3 plus I, 3 minus I. I want to make sure I got that right. I got it wrong. I'm sorry. I think I wrote that wrong earlier. It's 1 plus 3i. So my apologies if that was confusing earlier. Positive 6 and negative 1. And I found all of the zeros of f of x. All right, and that is the end of this problem. Hope that was helpful, and we will see you in the next video.